Welcome to the DX Today podcast, where you get facts and no hype.
It's great to be back.
Today feels significant. We're planting a flag. It is February 1st, 2026. And if you just look in the rearview mirror for a second, at the last 3, maybe 4 years, we have been on this absolute tear.
An absolute rocket ship.
Yeah, the launch of ChatGPT, the massive hype cycle, the billions and billions of dollars pouring into anything with a .ai domain name.
Yeah.
It felt like a perpetual party. Every single week was a revolution.
It was the honeymoon phase. I mean, we were all swept up in the possibility of it all. The magic of the technology was, well, it was so blinding that we didn't really look too closely at the plumbing. We just saw the magic show.
Right, the honeymoon phase.
Yeah.
But today we're looking at the State of the Union for artificial intelligence right now, early 2026. And I think it's fair to say the honeymoon is officially over.
Oh, it's over.
We've woken up, we've had some very black coffee, and the reality check has arrived. And you know what? It's a bit of a headache.
It's a sobering moment. The numbers we're looking at today, they tell a very, very different story than the headlines of, say, 2024. We're looking at a landscape where the investment has just been staggering. We're talking $30 to $40 billion in enterprise investment flowing into these systems.
30 to 40 billion, with a B.
With a B. But we're seeing something that researchers are now calling the GenAI divide.
The GenAI divide. That sounds a bit ominous. Is this about, inequality access?
In a way, but it's more about corporate winners and losers. We have this new report from MIT. It's called Project NANDA, and it paints a pretty stark picture. Despite that massive cash flow, despite every CEO on the planet promising an AI revolution in their quarterly earnings calls.
I remember those calls.
We all do. Despite all that, only a tiny fraction of these projects are actually, paying off.
So the money is absolutely gushing out the door, but it's not coming back in.
That's the short version, yes. And today, I just want to be clear, we're not here to just sit and bash the tech. We are not Luddites. But we need to unpack why they're failing.
Right. We're going to break down the technical flaw at the heart of this, something called robustness. We're going to look at how we fix the trust issues with things like explainability and governance. And then, and I've really been looking forward to this part, we're going to do a massive deep dive into a specific industry, e-discovery.
Okay.
To see how these dynamics play out in the legal world where the stakes are literally win or lose the entire lawsuit.
I really like that we're anchoring this in e-discovery later. It's so easy to talk about AI in the abstract, like, oh, it writes poetry.
Right.
But seeing how it hits the legal market, or accuracy is, it's the law. That's where the rubber really meets the road. But before we get there, we have to address the elephant in the room. You mentioned the MIT study, but there's a specific number in there that I looked at it 3 times to make sure it wasn't a typo.
You're talking about the failure rate.
I am. According to that 2025 MIT study, Project NANDA, and it's backed up by data from Complex Discovery, 95% of corporate AI projects are failing to deliver measurable returns. 95%. It's a staggering number.
Come on. That sounds like clickbait. If I failed 95% of the time at my job, I wouldn't have a mic in front of me. Is that number real?
It is real, but, and this is a huge but, we have to be very, very precise about how we define failure here. This is where the nuance gets lost in the headlines.
Okay, so break it down.
It doesn't mean the code crashed. It doesn't mean the chatbot speaks gibberish, though, well, we'll get to that later. It means the project failed to impact the profit and loss statement, the P&L.
Okay, so the tech works, the light turns on, but the business case is completely broken.
Exactly. Or maybe a better way to put it is that it works in a sandbox, but it doesn't work at scale in the real world. The study shows that only 5% of integrated AI pilots are actually extracting tangible value.
5%.
The rest are essentially really, really expensive R&D projects that never graduate to production. They're cool science experiments that cost companies millions and millions of dollars.
That is a very painful realization for a CFO who signed those checks back in 2024. And it's not just the MIT data, is it? We have user sentiment data that seems to say the same thing.
Right, there's the Zoom Info survey data. And this is interesting because it doesn't poll the executives, it polls the actual users, the go-to-market professionals, the sales teams, the marketers who are in the trenches.
The people actually using the tool?
Yes. And over 40% of them are explicitly dissatisfied with the accuracy and their reliability of their AI tools. So on one hand, you have a financial failure, and on the other, you have a user experience failure. They're connected.
Which brings us to the core question of this whole deep dive. If the hype machine is broken and the money isn't flowing the way we thought it would, What do? We can't just delete the software, right? The potential is still there.
We can't go back. The genie is well and truly out of the bottle. But the solution, it starts with understanding a concept that sounds very technical, but it's actually quite intuitive when you break it down. It starts with robustness.
Okay, let's unpack this. Robustness. To me, that sounds like, I don't know, a dark roast coffee or maybe a really sturdy dining table.
Yeah, right.
But in AI, frankly, I usually hear people talk about accuracy.
Yeah.
We want the model to be accurate. Why are we suddenly shifting the language to robustness? What's the difference?
This is a critical distinction, and it's one that the Frankie T source on AI evaluation metrics highlights just beautifully. Accuracy is usually measured on a test track.
A test track.
Yeah, imagine you're building a self-driving car. You test it on a closed circuit. The asphalt is perfect. The sun is shining. There are no other cars. The lines are freshly painted.
A perfect scenario.
Right.
And the car performs perfectly.
Right.
99% accuracy.
Right. It stays in the lane every time. That is accuracy. But robustness. Robustness is what happens when you take that car off the perfect track and you put it in downtown Boston in February.
Oh, boy. So potholes, sleet, aggressive drivers, pedestrians just jumping out into the street.
Exactly. Robustness is the model's ability to maintain its performance when the data gets noisy or varied or just completely unexpected. It's the ability to handle the absolute messiness of the real world without collapsing.
So accuracy is how well do I know the textbook, and robustness is how well can I handle a street fight.
That is a great way to put it, and here's where it gets really interesting, and frankly a little counterintuitive for people who aren't data scientists. Optimizing for robustness might actually lower your accuracy on that perfect test track.
Wait, hold on. Really? So making it better makes the score go down?
On the clean validation set, yes, it can. Because to make a model robust, you have to teach it to handle ambiguity. You have to introduce noise into its training.
You're intentionally making the test harder.
You have to. You have to teach it that sometimes a stop sign has stickers on it, or sometimes it's covered in snow, or that sometimes a cat looks like a dog if the lighting is really weird. That adds complexity. It might make the model slightly less precise on the super easy stuff, but it drastically improves its ability to generalize to new, unseen, messy data.
So we've been chasing the wrong metric. We've been celebrating 99% accuracy on the test, giving the model a gold star, and then we're completely shocked when the wheels fall off the second we deploy it to real customers.
And when the wheels fall off in AI, it's not just an error message on a screen. The consequences can be, well, disastrous. We're not just talking about a weird sentence in a poem. We have a hall of shame from the sources that really illustrates the cost of this fragility.
Yeah, I read through these examples, and honestly, a few of them are chilling. We have to talk about Tessa. This one really upset me.
Tessa is a prime example of a robustness failure in what we'd call a mission-critical domain. Tessa was a healthcare chatbot. It was designed by the National Eating Disorders Association. Its job was to help people, mostly young women, who are coping with eating disorders.
A very, very vulnerable population. The margin for error there is, it should be zero.
It is. It has to be. And due to a failure in handling the nuance of user interaction, a classic robustness failure, Tessa reportedly started giving actively harmful advice.
Harmful how?
It started suggesting dieting tips, weight loss strategies, and caloric deficits to people who were specifically seeking help for eating disorders.
That is a nightmare scenario. That's not just a failure, that's doing active harm. How on earth does that even happen? How does a model get it so wrong?
It happens because the model wasn't robust enough to handle the context. It likely had training data on health and fitness in a very general sense, so it saw keywords about weight and defaulted to its basic training. Here's how you lose weight. It completely missed the critical medical context that for this specific user, that advice is poison.
So it couldn't handle the noise in this case being the specific psychological condition of the user.
Exactly. It's a catastrophic failure of context. And then there's the physical world, Tesla.
Right. The source mentions an incident where a Tesla vehicle failed to recognize a pedestrian in a crosswalk. This is a computer vision failure. The unseen data, maybe with the lighting, the angle of the pedestrian, the clothing color blending in with the road, wasn't processed correctly.
That's the Boston in February problem again, but with life or death stakes.
It is. The model was accurate in thousands of hours of testing, but not robust in that one specific critical edge case. And then, of course, you have Clearview AI.
This one scares me from a civil liberties perspective, deeply.
It should. Clearview AI's facial recognition system wrongly identified an innocent person as a criminal. That is what the source calls a large-scale failure in the domain of justice. These aren't just glitches. The source notes that reported AI incidents averaged 79 per year between 2020 and 2023. And as adoption scales, that number will likely climb unless we fix this core robustness issue. So how do we fix it? I mean, if you're an engineer listening to this or a chief compliance officer who's terrified of your chatbot going rogue like Tessa, what do you actually do? You can't just, wish for robustness.
No, you have to engineer it. And engineers have a few heavy-duty tools in their belt. The first one is data augmentation.
Augmentation. Like steroids for data.
Sort of, yeah. It's deliberately training the AI on bad data. You don't just feed it perfect, grammatically correct sentences. You feed it misspelled words. You feed it slang, broken grammar, blurry images, audio recordings with background noise. You essentially inoculate it against the messiness of the real world.
So you teach it to read typos so it doesn't just freak out and shut down when a user makes one.
Essentially, you expand the training distribution to cover all the noise. Then there's a technique called adversarial training. This one is my favorite.
That sounds aggressive.
It is. This is where you intentionally attack your own model. You try to trick it. You use another AI or a team of humans, what we call red teaming, to find the perturbations.
Perturbations.
Small, almost imperceptible changes in the input that cause the model to fail catastrophically.
So it's like finding the exhaust port on the Death Star, that one tiny weakness.
Exactly that. You find the weakness in the lab. Maybe changing just one pixel in an image makes the AI think a panda is a gibbon, and then you patch it. The idea is, if you can break it in the lab, you can fix it before it breaks in the wild.
It sounds like a fun job professional AI breaker. And for the compliance teams, for the non-coders listening.
They need to set the metrics. You can't just say, make it safe. That's meaningless. You need to define specific robustness criteria. For example, a pharmacy chatbot might need a stability score of greater than or equal to 90% across all varied inputs.
And if it doesn't reach that number, what then?
Fallback mechanisms. This is so crucial and so often overlooked. If the AI is unsure if its confidence interval drops below a certain threshold, it shouldn't guess. It should hand the conversation over to a human. I don't know is a perfectly acceptable, even a desirable answer for an AI, provided it leads to a human who does know.
That seems to be the theme here. Humility. We need humble AI that knows when it's out of its depth. But robustness is only half the battle, right? Because even if the car handles the potholes perfectly, if I don't know why it decided to turn left into a dark alley, I'm not getting in the passenger seat.
And that brings us directly to the black box problem.
The black box. This is the stuff of sci-fi horror movies. The machine makes a huge decision, and we have absolutely no idea how it got there.
It's a very real problem, especially with the rise of deep learning and neural networks. As the Palo Alto network source points out, the simple if-then logic is just gone. It's obscured. In old school coding, you could look at the lines, if X happens, then do Y.
Right. It was readable. Human readable.
But in a neural network, you have millions, sometimes billions of parameters, these weights and biases, that are just numbers. It's a massive matrix multiplication. You put data in one end, a whole lot of math happens, and an answer comes out the other. But tracing the thought process is incredibly difficult.
So why does this matter? If the answer is right, does it really matter how we got there?
In high-stakes environments, it matters completely. Think about that radiologist again. An AI flags an X-ray and says cancer. The radiologist can't just take that on faith. She can't just say, okay, computer says so. She needs to know why the AI flagged it.
Right.
Is it a shadow? Is it the texture? Is it a glitch? Or is it actually a tumor? Without explainability, what the field calls XAI, there is no trust.
And without trust, adoption stalls. Which brings us back to that 95% failure rate. We have this fascinating case study in the sources about breast cancer diagnosis that really dives into the how of this, how we can crack open that black box.
Yes, this study is a perfect example of XAI in action. It's really cool. They used the UCI breast cancer dataset. It's a standard benchmark. About 569 data points with features like the radius of the cells, the texture, the perimeter, the smoothness.
And they introduced these two. I'm going to call them the detectives of XAI, LIME and SSAP. Now, I want to spend a minute here because these names get thrown around a lot in our world, but I want to understand what they actually do.
Let's break them down because they're different but complementary. These are algorithms designed to explain other algorithms. Let's start with SHP. SHAP stands for Shapley Additive Explanations, and it's actually based on game theory from the 1950s.
Game theory, like The Prisoner's Dilemma and John Nash.
Similar field, yes, from Lloyd Shapley. Imagine you have a team of people working on a project, and you get a big payout at the end. Shapley values are a mathematically fair way to calculate exactly how much each person contributed to the win.
Okay, so Alice did 40% of the work, Bob did 10%, so they get that share of the bonus.
Exactly. SHE does that for the model's features. If the model predicts malignant, SHAP calculates how much credit the texture feature gets, how much radius gets, and so on for that specific prediction. It gives you a really clear view of feature importance.
Okay, so SHA tells us who the MVP of the data is for any given decision. What about LIME?
LIME is different. It stands for Local Interpretable Model Agnostic Explanations. It takes a different approach. It doesn't look at the whole game, so to speak. It looks at one specific instance. It takes that one X-ray, that one patient, and it perturbs it slightly. It changes it a little bit here and there to see what happens.
It's like copes it to see how it reacts.
It shines a bright flashlight on the local area around that decision. It says, for this specific patient, the model made this decision because of these 3 pixels in this quadrant. If those pixels were a little lighter, the decision would have flipped. It's a local explanation.
So SHE is like the team manager giving out performance bonuses at the end of the season. And LIME is the detective at the crime scene looking for the specific fingerprints on the murder weapon.
That is a brilliant analogy. Absolutely brilliant. And the key takeaway from the study wasn't just using one or the other, it was the synergy between them.
Because if the manager and the detective agree on who the culprit is.
Exactly. If LIME and Esche both agree on why the diagnosis is cancer, say, they both point to the mean texture and worst perimeter as the deciding factors, then the doctor can have extremely high confidence. It enables true human-machine interaction. The doctor adds their own expertise to the AI's math, but they're both looking at the same evidence.
That makes so much sense. It's about verification and confidence. But XAI isn't just for doctors. We have another case study here that felt a bit more invisible. It's about environmental monitoring, specifically EMF and 5G.
This is a great example of AI working in the background of our cities, affecting all of us. We're rolling out 5G, we're moving toward 5G advanced and eventually 6G, and people are, rightly or wrongly concerned about RF, EMF exposure, radio frequency, electromagnetic fields.
Right, I see these headlines all the time. People worry about cell towers near schools or in very dense urban areas. They want to know if they're being, microwaved.
Exactly, and you can't physically measure every square inch of a city with a handheld meter. It's just physically impossible and cost prohibitive. So telecom companies and regulators use machine learning models to predict the field strength based on dozens of factors: building density, population, antenna height, distance from the tower, etc.
But again, if the public is going to trust these predictions, if a school board is going to trust that it's safe to put a playground in a certain spot, they need to know the model isn't just making it up to save the telecom company money. The trust issue is huge.
Precisely. And the study referenced in our sources specifically compared different XAI models, again, utilizing tools like SHAP and LIME, to ensure these predictions are valid for public health policy. They even reference specific studies in Greece, Spain, and Switzerland, all trying to measure exposure in what they call microenvironments.
Microenvironments. What does that mean?
It means a schoolyard, or a specific street corner, or even a single apartment balcony. These are small pockets where radiation might behave very differently because of reflection off a building or absorption by trees. If the AI predicts low exposure, XAI can tell us it's because of the building shielding the area, not because of a bug in the code. It bridges that critical gap between a mathematical prediction and a public safety policy.
So we have robustness, which is about making the model tough enough for the real world. We have explainability, making the model transparent enough for us to trust. But who enforces all of this? Who is the referee in this game?
That brings us to the adult in the room, governance.
The exciting world of regulation. But honestly, after the Wild West of the last few years, I think we are all secretly ready for some rules of the road.
We are. The industry itself is craving certainty.
Yeah.
And we're seeing a major shift from voluntary ethics principles, which are, nice but toothless, to hard legal frameworks. We have the EU AI Act, the UNESCO recommendations. But I want to focus on 2 specific frameworks from our sources that are really practical and happening now: Canada's AIA and ISO 42001.
Let's start with Canada. They have something called the Algorithmic Impact Assessment, or AIA. Is this just another bureaucratic checklist?
Well, it looks like a checklist. It's an open source questionnaire, essentially. But what sets it apart is its philosophy. It doesn't just ask how the algorithm works. It focuses on how the algorithm is used.
That's a really important distinction. The same algorithm could be used to recommend a movie or to deny someone a loan. The impact is totally different.
Exactly. The risk is in the application, not the code itself. The AIA defines an automated decision system very broadly. It's anything that assists or even just replaces human judgment.
Assists or replaces. So even if a human stamps the final paper, if the AI did all the sorting and ranking beforehand, it counts.
Correct. You can't hide behind the human in the loop excuse if the human is just rubber stamping the AI's recommendation. And the transparency this forces is really powerful. There's a great anecdote in the source about the International Youth Work Program. It's a triage tool for visa applications in Canada.
Sounds pretty bureaucratic and boring.
It is, but a researcher named Tao used the AIA process to investigate it and was completely surprised to find that because of this assessment, the government had to make their gender-based analysis documents public.
Wait, explain that. What does that mean? What did they find?
It means the assessment forced the government agency to document and then reveal how the tool affected different genders and age groups. That internal documentation, which might have stayed hidden in a file cabinet forever, became public record because the AIA process requires transparency on impacts. It forced the government to show its homework on fairness.
That is real accountability. It's saying if you use this tool on the public, you have to tell the public who it might hurt.
Now let's pivot to the corporate side. ISO 42001. We all hear ISO and we think of, factories or quality control.
Think of ISO 42001 as the gold standard for AI management. It was just introduced in 2023, and it's a management system standard. It sits right alongside the big ones like ISO 9001 for quality or ISO 27001 for information security.
For listeners who don't live in the corporate world, ISO 27001 is basically the badge you need to prove your company isn't going to get hacked immediately. It's a huge deal.
It's the cybersecurity standard, right?
Yeah.
If you want to sell software to a bank or a hospital, you need to be ISO 27001 certified. Yeah. Well, ISO 42001 is intended to be that, but for AI safety and governance.
So it's a certification a company gets to prove they aren't being reckless with AI.
Exactly. It has 38 specific controls. It covers the big five: security, safety, fairness, transparency, and data quality.
Why would a company go through the pain of doing this? It sounds like a lot of paperwork and auditors. It is a massive amount of paperwork. But it's about proactive risk management. It helps you spot the risks before you become the next Tessa or Clearview AI headline. But also, from a purely business perspective, it plugs right into ISO 27001.
So if you already have the cybersecurity badge, this is like an add-on pack.
In a way, it integrates with that same management structure, so it's an easier sell to the C-suite. You aren't building a whole new bureaucracy from scratch. You're extending your existing security culture to cover your AI systems. It's about being able to look your clients in the eye and say, we have controls in place. We aren't just winging it with this stuff.
And speaking of clients, I want to take all of this, the failure rates, the robustness issues, the need for governance, and apply it to a real-world industry. We promised a deep dive into e-discovery. Now, for the uninitiated, e-discovery sounds like a channel on cable TV about finding old electronics.
It does, doesn't it? But for those who aren't lawyers, e-discovery is the absolute backbone of modern litigation. It is the process of identifying, collecting, and producing electronically stored information, ESI, for legal cases.
It's basically finding the smoking gun in a giant mountain of emails.
A mountain of emails, Slack messages, text messages, Microsoft Teams chats, Zoom transcripts. It is a massive, messy data problem. If a big company gets sued, they have a legal obligation to turn over every single relevant document. If they miss one, they can lose the case. If they accidentally turn over something privileged, they can lose the case.
So the stakes are, quite literally, bet the company.
High stakes, high volume, and incredibly tight deadlines. It is the ultimate stress test for AI.
And a massive market. We have data here from the Complex Discovery Market Size Mashup for 2024-2029. Lay the numbers on us.
The market is growing from $16.89 billion in 2024 to a projected $25.11 billion by 2029. That is a very healthy growth trajectory. It's a big business.
$25 billion. That sounds like a boom. So everyone in e-discovery must be popping champagne corks, buying yachts.
Well, not exactly. There's a strange conflict in the data. We call it the business confidence conflict. On the surface, things look great. 59.38% of professionals rate the current business conditions as good. That is up significantly from previous years when normal was the benchmark.
Okay, so they feel good, they're busy. What's the catch?
The catch is liquidity, cash flow.
Yeah.
The survey shows that days sales outstanding DSO is increasing. 18% of respondents say it's taking longer and longer to get paid by their clients.
Oh, the classic, the check is in the mail.
Exactly. So you have a booming market, you're doing lots of work, but the cash isn't coming in the door fast enough. That creates a serious liquidity crunch. You have these huge expenses to manage the massive data volumes. You have to pay for the servers, the software licenses, the people, but your clients are slow walking the payments.
Why are they doing that? Is it just the general economy?
It's caution, and it ties all the way back to that 95% AI failure rate. Corporate clients are scrutinizing bills like never before. They're asking, why did this review take so long? Why isn't the AI you sold me doing this cheaper and faster? They're pushing back hard on costs.
And I imagine the data volumes aren't getting any smaller while they argue about the bill.
They are exploding. We call it the holy trinity of problems in e-discovery right now. Crushing budget constraints versus ever-increasing data volumes versus new and more complex data types.
What kind of new data types?
It's not just email anymore, it's ephemeral messaging. Things like Snapchat, disappearing signal messages and collaboration logs from platforms like Notion or Monday.com or Asana, all the ways we work now.
Trying to capture a disappearing message for a court case sounds like an absolute nightmare.
It is a technical headache and a governance nightmare. If you're a bank and your traders are using Signal to hide deals from compliance, how do you collect that for a lawsuit? The answer is you probably can't. It's a huge source of risk.
So with all this complexity and growth, surely companies are buying each other up. Consolidation. The big fish eating the little fish.
You would think so. That's the logical move. But surprisingly, M&A activity in the space has crashed.
Really? In a growing market?
We're calling it the pause. Back in 2021, there were 55 M&A deals in this space. It was a complete frenzy. In 2025, just 21.
That is a huge drop. That's more than half.
Right.
What happened?
And the pattern was bizarre. It was a spike and plateau. June of 2025 saw a sudden frenzy, 6 deals in 1 month. But then you look at February, April, and December. 0 deals. Nothing.
Just crickets. Why the caution?
Capital is cautious. Private equity and venture capital are looking at that 95% AI failure rate we talked about earlier. They're looking at the broader tech sector cooling off. They're thinking twice before writing a huge check. They aren't buying the hype anymore. They want to see profitable, robust business models. They want to see SISU, which we'll get to.
Let's talk about the money that is changing hands, though. The actual cost of services. We have the Summer 2025 e-discovery pricing survey. This gives us the real hourly rates. I want to go through this because it tells us the cost of truth in a lawsuit. Let's start at the front door of e-discovery forensics, collecting the data itself.
This is a pretty mature part of the market, so the pricing is fairly standardized. For on-site collection, that means sending a forensic expert to an office to physically image a hard drive. 70% of providers are charging between $250 and $350 per hour.
That seems hefty. $350 an hour to copy some files.
It sounds high, but you aren't paying for the act of copying. You're paying for the chain of custody. You're paying for the guarantee that those files haven't been altered one bit. If that collection process is challenged in court, you need that expert to be able to testify under oath about every step they took.
And speaking of testifying, what does the expert witness themselves cost? The person who has to stand in the box and get cross-examined.
That's the premium service. 30% of providers charge over $550 per hour for expert testimony.
Wow. Okay. You're paying for credibility under fire. You're paying for someone who can withstand a brutal cross-examination from an aggressive opposing counsel who's trying to destroy their reputation and their findings. That is a very specific, very high-stress skill set.
Indeed. Now, let's get to the biggest line item, the most expensive part of the whole process. The review.
Document review. This is where human beings, often armies of contract lawyers, sit and read the documents one by one to determine if they are relevant to the case or protected by privilege. It has historically accounted for 60 to 80% of the total spend in a case.
That is the whale. And this is the part where everyone for the last decade has said, AI will fix it. Robots will read the docs. Why are we still paying humans 80% of the budget for this?
Because of robustness. This ties it all together perfectly. Lawyers are, by nature and training, incredibly risk-averse. They are terrified of AI hallucinations. If a human reviewer misses a privileged document, say an email between the CEO and the general counsel, and hands it over to the other side, that privilege is waived forever. You can't get it back. The bell has been rung. You can't unring it.
Exactly. So legal teams are extremely cautious. They use Gen AI to assist to summarize long documents, to find patterns, to ask questions like, show me all emails where they discussed hiding the debt. But they rarely let the AI make the final produce this document or do not produce this document decision without a human checking the work.
So the lack of robustness in the AI models is literally costing this industry billions of dollars a year in human labor.
Precisely. However, there's a fascinating trend emerging in markets outside the U.S. The survey notes that markets that didn't have these massive legacy armies of human reviewers, places that don't have the big sweatshops of document review like we see in the U.S. or India, they might just leapfrog the whole model.
Like how developing nations skipped landlines and went straight to cell phones.
It's the exact same concept. They might skip the offshore human review phase entirely and go straight to AI-first workflows because they don't have the sunk cost of the old way. That could completely disrupt the entire global labor market for legal work over the next decade.
So, to sum up this section, we have a market that is growing, but it's cash-trapped. We have technology that is promising, but it's untrusted. And we have a regulatory landscape that is rapidly hardening around it. That's the state of play in early 2026.
It's a major transitional moment, a real inflection point.
So what does this all mean? If we zoom all the way out, what's the big takeaway for the listener today?
I think the headline is this: the gold rush is over. We are now officially in the construction phase.
No more panning for gold in the creek and getting lucky. Now we have to build the mine with infrastructure and safety rules.
Precisely. That 95% failure rate told us that just throwing money at magic doesn't work. We've stopped looking for magic and we started demanding robustness. We finally realized that accuracy in a sterile lab isn't enough. We need systems that can handle the potholes and the messiness of the real world.
And we've learned that trust isn't just a vibe, it's a feature set. It has to be engineered.
Yes. We can't use what we don't understand. That's why explainability, XAI, is exploding as a field. We need to know why the AI says it's cancer or why it says the 5G tower is safe. And we need the governance, the ISO 42001 certificate on the wall, to prove to our customers and to regulators that we are responsible stewards of this technology.
And in a real-world industry like e-discovery, the money is there, $25 billion of it. But it's going to flow to the companies that can solve the boring problems. The operational problems, liquidity, data variety, cross-border pricing complexity. It's not about who has the coolest chatbot anymore. It's about who can actually get the job done, get paid for it, and not get sued in the process.
It sounds a lot less exciting than the Wild West days of 2023 maybe, but it's a lot more sustainable.
It is. And there is one final concept I want to leave our listeners with. It came up in the context of one of the sources, which was dedicated to a leader in the e-discovery space we recently lost. It's a Finnish concept called sisu.
Sisu. I love this concept. It's so powerful.
Tell us about it, because I feel like this is what we've been talking about for the last hour without actually putting a name on it.
It is. Sisu is one of those words that's hard to translate directly into English. It means grit, but it's more than that. It's determination. It's guts. It's this deep internal fortitude, the ability to keep moving forward in the face of extreme adversity, specifically when the odds are stacked against you.
So facing into a headwind and just continuing to walk.
Exactly. And we have spent years obsessing over AI metrics like accuracy, precision, recall, F1 score. Maybe the missing metric in AI right now is sisu.
The ability to stick with the transformation when the ROI isn't there in month one, when the pilot project fails.
The ability to push through that 95% failure rate.
Yeah.
To do the unglamorous work of data augmentation, to sit there and label the noisy data for hours on end, to implement the governance paperwork, to clean up the data swamps that have existed for decades. That isn't flashy work. It won't get you on the cover of Wired magazine.
Not at all.
But it's the work that will turn that 5% of successes into 50%. It's the construction work.
Maybe that's the big reality check of 2026. The magic didn't save us. The AI didn't do the hard work for us. Now we have to save ourselves with our own hard work.
Facts. No hype, just sisu.
I love it. Sisu. That's the word for 2026.
I think it has to be.
Thanks for listening to the DX Today podcast. We hope you feel a little more robust, a little more explainable, and ready to face the reality check with some sisu of your own.
Until next time.